Okay, can everybody see this okay? We got going here. So in Desmos, you're going to get to learn Desmos in detail throughout the year. We will even do, we'll do sections, like I said earlier on all the tests, we'll do sections, we'll do graphing utility sections where you have access to this kind of a thing, to use the Desmos graphing calculator. There'll be parts where you won't also. But this is a big part, like on the SBAC test, you have access to this. So you'll be using this in math classes from here on out. So if I graph something like this, y equals 2x minus 3, if I want to graph that line, first of all, let's just kind of review how we sketch lines. So how's that work? What am I going to do? There we go. So how am I going to sketch this line? 2x minus 3. Remember, our goal is when we're sketching a line, and I'm actually going to be graphing it up here, but pretend we're sketching it for a second. We just want to get 2 points and connect and extend, right? So where's the first point? Oh, negative 3. Okay, the y-intercept. Good. So we can graph the point, I'm going to call this, okay, so we can graph the point 0, negative 3, right? X is 0, y is negative 3. And there it is right there. Agreed? Okay. We need another point. How am I going to get another point? Up 2 over 1. So my x value, I'd be just doing this on paper or on graph paper, but my x coordinate is my y coordinate is going to change by positive 2, isn't it? So instead of being negative 3, it'd end up being negative 1 if I go up by 2, right? And I'm going to run by 1. So my x coordinate is going to increase from 0 to 1. That look good? There's my original. Now I'm going to rise by 2 and run by 1. And that matches the line, doesn't it? Okay? So let's check some points here then. You tell me, is this point that I'm graphing up here, you tell me, is this going to be a solution or not? The 0.57. There's my equation right there. Is the 0.57 going to be a point on the line or not? Hearing some yeses. How come? You're right. It is going to be on the line. How do I know? Without actually graphing it, how do I know? Here's my original equation. And I'm checking the point 5 negative cents, or 5 positive cents, sorry. If I plug it in, right? If I plug in the x and y values, what's that going to give me? I'm going to get 7 equals 2 times 5 minus 3. Is that true?
Yes.
It is. I get 7 on both sides. So that's a solution, right?
Right.
Okay. What's that mean if I plot that point on Desmos here? What's going to happen? If I turn that one on, what do you know? It's on the line. Should that be a surprise?
No, not at all.
If it's a solution, if it satisfies the original equation, do you see that one connection we can make, and we've already talked about this a little bit, but this is a really important one. Do you see that one connection we can make is those coordinates then, those x and y values, when graphed, have to be a point on the line? That's really what a line is in this case. It's a collection of all the solution sets, all the ordered pairs graphed on the xy plane. So if I pick one instead, how about this? Let's pick the point Thank you. So how about if I pick the point 4, 1? If I plug that into the equation, does it work? Doesn't work. 2 times 4 is 8 minus 3. I'm going to end up getting 5 on the right side of the equation, and 1 for y. It doesn't work. 1 doesn't equal 5, so it does not satisfy the original equation. Should it be on the line? No, it's not, right? Falls off the line. That's a non-solution. It doesn't fall on the line because it doesn't satisfy the equation. It doesn't work in the equation. Okay, so no big deal. I mean, we've already kind of talked about that. So next issue then. Let's try some of these points relative to an inequality instead. Okay, let's try some. So now we've got the inequality. Let me make this bigger. We've got the inequality y is less than 2x minus 3. Okay, let's just check some points here. Let me scoot this up a little bit. So, okay, let's check some points. What if we take the value, I'll just throw some out there arbitrarily. What if we pick the point 0, let's say we pick the point 0, negative 1. If I plug those values into the inequality, let's see what happens. Plugging 0 in for x and negative 1 for y. Is that true? We end up with the answer. Negative 1 is less than, what's 2 times 0 minus 3? True or false? Negative 1 is less than negative 3. False. That does not satisfy the inequality, right?
Right.
So do you think that's going to be part of the solution of this inequality then, if it didn't work? No, it's not. So if we graph the point 0, negative 1, that's not going to be part of the colored part of the graph, whatever that's going to look like for this inequality, right? What if I try the point, how about 1, 1? Is that going to work? I get 1 is less than 2 times 1 minus 3. So I end up with 1 is less than negative 1. True or false? False. So the point 1, 1 is also not part of the solution. Okay, let's try the point 2, 0. If I plug 2 in for x, I get 4. 4 minus 3 is 1. On the other side, I get 0. Is 0 less than 1? It is. Right, so that's true. So that means that is part of the solution. How about, just one more. How about 1, negative 3? If I plug that one in, I'm going to get, for my y value, I get negative 3. For my x value, I get 1. 2 times 1 minus 3 is negative 1. Is negative 3 less than negative 1? It is. So that's also a point that's in the solution, right? Okay. Notice that the 2x minus 3 is the same as it was for our line, right? We started off with the line y equals 2x minus 3, and now we're looking at the inequality. Y is less than 2x minus 3. Do you think that line is related to where the parts of this xy plane where we have solutions and the parts that we don't? How? Here's the line, right? Here's the red line. Y equals 2x minus 3. We've noticed, we've only taken a few points, but what do you think is going to happen if I try 100 points instead of just 4 total? The green ones are the ones that let's get rid of this guy. The green ones are the ones, you can't. Let's do that. The green ones that I just graphed were solutions, the red ones were non-solutions. What do you think? Where are more green ones going to show up? Okay, this side of the line, right? Where are more red ones going to show up? Other side of the line. So the line is there to divide this plane up into 2 different half planes, one of which is going to contain all the solutions and the other one which is not. Agreed? Okay, what about the line itself? What if we pick a point that's on the line, like 0, -3? Okay, if I plug in 0, -3, I get -3 is less than -3. Is that true? No, it's not. -3 is equal to -3. So the line itself in this case is actually not part of the solution. So I'd really, if I wanted to be more accurate here, I need to change the way I draw the line. The line needs to be written instead as a dashed line, which I'm just going to do by hand. So there's my boundary line, right? If I want to shade all of the possible solutions, I'm just going to shade everything to the right of and below that line, okay? So here's what the inequality looks like. If I turn this on in Desmos, there it is. What did I do? Oh, I drew over the wrong dots. That's right. Okay, let's get rid of those. Right, those are the two dots I should have drawn through, right? I think I erased them. They were up here earlier. Yeah, the blue ones, right there. So notice it's a dashed line, and I'm shading everything on the side that includes those points, right? So we didn't need to probably use all those points, did we? We could have been a little smarter about this. How could we have gotten that graph more easily? Is there a general strategy we could use here? If I want to graph this inequality, so here it is. Y is less than 2x minus 3. How could we go about getting that graph more quickly and easily? Where would we probably start? Okay, so the fact that it's a less than, sure, we'll take it. So we know we got an inequality. But think about the parts. I mean, how the region that's shaded. Yeah, we shaded to the right and below the boundary line, right? We started off with the line 2x minus 3, right? I mean, this is the line that we started with. There's the boundary line. Agreed? So we got to get that first, because that's what's going to divide the parts that get shaded, which includes the solutions, from the part that doesn't get shaded, right? So step one is always going to be graph the boundary line. Okay, we did that. You guys told me a long time ago that the line 2x minus 3 has a y-intercept of -3, and then we would just rise by 2 and run by 1 to get a second point. And then we would connect those with a line, but we got to be careful to remember that because we're not including an equal sign there, it's going to be a dashed boundary line, right? It doesn't include the line itself, it's just a boundary. How do I know which side to shade? We picked a bunch of points, but how many did I really need? One, right? Either it's going to pass, we can pick some random point, and if it's a solution, we'll shade the side that includes that point. If it doesn't pass, if it doesn't satisfy the original inequality, then it's not a solution and we shade away from it, right? What would be the easiest, John, what's the easiest point to pick to test, do you think? Of all the points on the xy plane, what would be the easiest one to substitute values for x and y in? Okay, actually 0, -3 is one we don't want to use because it's right on the line, right? So 0, -3 is not going to help us. 0, -3 is not going to work, but what does that tell me to do? So if I pick that value and it doesn't work because it's a dashed line. I still don't know which way to shade. What would be probably what are the easiest values to substitute? 0, yeah, zeros, right? Plug in 0 and it's really easy to see what happens. If you multiply by 0, it becomes 0, right? So let's always choose, if we can, let's always choose the point 0, 0. If it's on the boundary line, we can't. Then we got to choose some other point, but usually it's not. So if I plug 0 in for x and 0 in for y, what do I get? 0 is less than 2 times 0 minus 3. 0 is less than -3. True or false? False. So if that's my test point and it fails, I got to shade away from it, right? That's how we get that graph. Okay? Make sense? Okay. All right, there's another way you can do this too. Think about what it means, and this is kind of optional. This doesn't show up in the books, it doesn't show up anywhere really. This is just my own little trick, but it's a pretty good little trick. When I look at this inequality, y is less than 2x minus 3, isn't the mx plus b part the part that's just giving me the boundary line, right? The parts that I want to shade really are determined here. If I'm picking y values that are less than my boundary line, is y a horizontal or a vertical variable? Vertical, right? So which is the positive y direction? What's the positive y direction? Positive x direction is off to the right, isn't it? Negative is off to the left. Positive y direction is what? Up. Negative is down, okay? So if I want to pick all the y values that are less than my boundary line, am I going to be shading, does that mean below or above the line? Y is vertical. So if I want to pick y values that are less than something, am I going to move down or up? Down, right? Because the positive y direction is up and the negative y direction is down. So all you have to do if you want to see which way to shade, if it's written in the form y is less than mx plus b or y is greater than mx plus b, is just focus on the first part of it. If it's y is less than something, I know that I'm shading down, right? Make sense? Okay, try one of these. You just sketch this on your paper here. Just try this. Let's do... Okay, try that. I'm going to make one more little change. Let's do this. So there's what I want you to investigate. See if we can get a quick graph of y is less than or equal to negative 1/2 x plus 4. Doesn't have to be accurate. Just do a quick sketch in your notes. So what are we going to do first? What's the first step? When we're going to try to graph an inequality like this, where do we start? What do we do? What do we do first? Plot what? Okay, but so what are you doing? You plot the y-intercept. Well, what are we trying to graph first? Boundary line. Start with the boundary line, right? And then we're just going to figure out which way to shade. Either use a test point or use my trick. I don't care which one. Okay, for the boundary line, where do I start? What's my first point I'm going to plot?
0, 4.
0, 4, okay. So I got a point, there's a point that's on the y-axis at 4. What am I going to do from there? Rise and run. Okay, so I'm going to rise by, how much? -1. So I'm going down 1, and I'm running by, no, always to the right. So the negative goes with the rise. Right? Negative rise means down, but the run is always going to be to the right. So I run by 2, and there should be my second point. Okay?
Pardon this interruption. The symphonic drum line needs to go to the music room immediately. That's the symphonic drum line. Needs to report to the band room immediately.
Okay? So symphonic drum line, go for it. So then all I got to do now is connect and extend, right? There's my boundary line. Is my boundary line going to be solid or dashed in this case? Okay, how come? You're right. Okay, good. It includes the equal to sign, and that takes more ink, doesn't it? More ink to draw the equal sign, more ink to draw the solid line to the dashed line. Okay, good. Now, am I going to shade up or down from the line? I'm going to shade down. Good. And what? How do I know that? Okay, it's a less than. Good. So if we notice right here, whoops, that's not going to work, is it? Notice that when I get the y by itself, I have y is less than or equal to blah. I don't care. Less than or equal to the boundary line, which means I'm going to shade down from the boundary line, right? If I don't use that trick, how could I use a test point? What would I do? So if I try 0, 0, if I try the point 0, 0, if I plug 0 in for y, I get 0. If I plug 0 in for x, what's negative 1/2 times 0? 0. So I could just eliminate any term with an x or a y, and I just get a 4 on this side. Is 0 less than or equal to 4? Yes, it is. So that tells me that the test point has to be included, so I'd shade towards the test point. Right? Either way, this is what I should get. Oops, that's the wrong one. This one. How's that? There we go. Right? Okay. One more example and we're good. Let's pick one. This time we're going to pick one that's written in a different form. So this time we're going to try this on your paper. We're going to try one in standard form. So let's do, actually I got one right down here. Let's do that guy. So let's do, right there. 3x minus 4y is less than 12. First step, what's it going to be, Cooper, first step? If I want to graph this thing up here, what do we got to get first? Boundary line. Good. Boundary line, and then second step, we'll figure out which way to shade. Go. Let's get the boundary line. All we need are 2 points, right? Now, you could go through the hassle of solving for y here, but I don't recommend it. There's a quicker way, right? What was our trick? When we have this thing written in standard form, how can we easily find 2 points? What do we do with this? An idea? Okay, the intercepts? Intercept. Okay, how could I find the x-intercept? What's happening at the x-intercept? That's on the x-axis, right? So what has to be true there? Y is 0, right? Y is 0 on the x-axis. So if I want to find the x-intercept, y is 0, that means I just cover up that term and solve for x. Right? Because if I multiply by 0, if I plug 0 in for y, 4 times 0 is 0. It goes away. So what am I left with? 3x equals 12. What's x? 4. So we got 1 point is the x-intercept 4. What about the y-intercept? What would I do for that? Same thing, but what am I setting equal to 0? X. Okay. So if x is 0, negative 4y equals 12. Solve that. Y is negative 3. Okay, so there's the other point. And now I'm going to connect and extend. Do I want a solid or a dashed line here? If I'm doing dashed. Okay, so we need a dashed line. Okay. Now this one, it's going to be, maybe it's easier to just pick a test point here because the y is not by itself, right? Still going to work. So which point do we test? 0, 0. Let's try 0, 0. If I pick 0, 0, we plug 0 in for x and 0 in for y. So what's the whole left side become? 3 times 0 minus 4 times 0 is 0. Is 0 less than 12? It is. So I'm going to shade towards that point, right? Okay. There is a way, now this is optional, but I think this is a pretty good way. There is a way you could use my trick on this. If we're going to start with this equation, 3x minus 4y is less than 12. We've already graphed the boundary line, right? So if I were going to go through the steps to get the y by itself, what would I do? Okay, I could do that. Let's go ahead and just say let's just say we're going to subtract 3x to this side, right? Do I care what I get on the right side? No, I don't. All I care about, when I'm all done, I want to know I have y is what? Greater than or less than blah. I don't even care what's on the other side, right? I just want to know, am I going to end up with y? What's going to be the inequality next to y? And that's going to tell me which way to shape, right? So I'm going to subtract the 3x away. It's gone, right? Now what? Divide by negative 4, right? So I end up with negative 4y is less than some number. We don't care, right? Divide by negative 4. If I divide by negative 4, what do I have to do to the inequality? Gotta flip it, right? So I end up with y is greater than blah. I don't care what's over there, but I have y is greater than, right? So which way am I going to shape? Up. Did I even have to write any of that stuff down? I'd say no. You can just inspect the thing and see what's going to happen. If I know that I have a negative number in front of y, when I divide, it's going to turn that inequality around, right? So I could just kind of think ahead a little bit and not even do the algebra, just anticipate what's going to happen. Either way, I'm going to get this when I graph it. Okay? Make sense? Yeah. Go. You got it. Grab a Chromebook if you don't have one.